Hi everyone. Today we're going to study existential quantifier. Let's begin with existential quantification. Many mathematical statements assert that there is an element with a certain property. Such statements are expressed using existential quantification. With existential quantification, we form a proposition that is true if and only if p of x is true for at least one value of x in the domain. Let's have now the existential quantifier. The existential quantification of p of x is the proposition there exists an element x in the domain such that p of x. We use the notation reverse e of x, p of x for the existential quantification of p of x. Here, the reversed e is called the existential quantifier. The existential quantification reversed e x p of x is read as there is an x such that p of x, or it can be like this: there is at least one x such that p of x, or it can be like this: for some x p of x. A domain must always be specified when a statement for some x p of x is used. Furthermore, the meaning of for some x p of x changes when the domain changes. Without specifying the domain, the statement for some x p of x has no meaning. Let's go now to the truth value of existential quantifier. The existential quantifier for some x p of x is true if there is at least one x for which p of x is true. Or this is false if p of x is false for every x in the domain. Example 1. Let p of x denote the statement x is greater than 3. What is the truth value of the quantification for some x p of x, where the domain consists of all real numbers? Since x is greater than 3 is sometimes true, for instance, when x equals 4. The inequality here becomes 4 is greater than 3. Then, the existential quantification of p of x, which is for some x p of x, is true. Example 2. Let q of x denote the statement x equals x plus 1. What is the truth value of the quantification for some x q of x? The domain here is the real numbers. Since q of x is false for every real number x, the existential quantification of q of x, which is for some x q of x, is false. Example 3. What is the truth value of for some x p of x, where p of x is the statement x squared is greater than 10? The domain here is the positive integers not exceeding 4. The domain is 1, 2, 3, and 4. And the proposition for some x p of x is the same as the disjunction p of 1 or p of 2 or p of 3 or p of 4. Since p of 4, which becomes the statement 16 is greater than 10, that is the 4 square is greater than 10, is true, it follows that for some x p of x is true. I hope you learned something from this video. See you again next time.